Welcome friends to the Formula Engineering classroom, and in this lecture we'll understand the concept of hydrostatic forces on submerged bodies. So as we are saying, that is hydrostatic forces means we are saying that is fluid is at rest condition, static. So when the fluid is at rest condition, in that case there is no inertia forces are available because the fluid is not moving. Also in that case, when the fluid is not flowing, the shear forces or viscous forces are also not present in that case. Okay, so I'm writing here for static fluid, inertia force is 0, there is no motion. Shear force is 0. Okay, now so only forces present in this case are the pressure force and the weight of the body. Okay, so we are saying present forces in this case, forces available here are pressure force and weight. So these two forces are available in this case, but in this section we are only concerned about the hydrostatic forces on submerged bodies. Means we are not concerned about the weight of this body, we are only concerned about that the static fluid exerting on the surface. Okay, we are only concerned about that force which one the static fluid is exerting on the submerged body. So again here we are not concerned about the weight of the body. So in this section we will only deal with the pressure force. Okay, we only deal with the pressure force. Now, so now we are saying that is we are only concerned about the pressure force. So we have consider some cases here. So first case, that if I'm not using this space here. So I'm writing first case, case 1. And case 1 I'm saying hydrostatic force on horizontal plane surface. Okay, now so let's suppose this is the free surface of fluid that is at rest condition. Obviously fluid is rest condition, we are considered only about the static conditions. This is the free surface, and in this fluid there is some horizontal plane surface is submerged. Okay, so this is our horizontal plane surface here. Okay, and net we are saying this is at a distance y below the free surface, and at around here is the center of gravity of this plane surface, and let we are saying the area of this one is a here. Okay, so this is our case 1, that is hydrostatic force on horizontal plane surface. So now we know according to the hydrostatic law, that is as the depth increases the pressure intensity also increases. So we can draw like that. this point. So if rho is the density of this fluid and g is the gravitational acceleration in this case, so at this point the pressure intensity will be rho gy. It's obvious. So it will look like this one. So here at this point the pressure intensity is rho gy. So I'm writing the P is equals to rho gy. Okay. Now according to Pascal's law, we know in a static fluid at a point the pressure intensity remains same in all directions. So I think the pressure intensity in this direction at this point and this direction at this point will be same. Okay, so this will be same here. And I think this is a horizontal plane surface, so every point on this surface has the same depth from the free surface. So the pressure intensity at every point will be same. So the pressure intensity is same at every point, so we can draw like that. Every point had same depth on this plate from the free surface of fluid. That's why the pressure intensity at every point will be same. It look like this one. Okay, so every arrow has the same pressure intensity, that is equals to rho g y here. So now, so we know the pressure intensity, and this pressure intensity is uniform throughout the surface, and we know the area, so we can calculate how much force this pressure will exert on the surface. So this fluid is exerting a force over here, so we can write F is equals to pressure into area. So pressure intensity is rho gy, that is same everywhere, into area of this one. So this one is the force exerted by this fluid over this flat surface or plane surface of area A, that is in horizontal position. Now you can notice here I am multiplying pressure to the area directly, because in this case the pressure is uniform throughout the surface. But if the pressure is not uniform throughout the surface, in that case you can't multiply pressure directly to the area. In that case you have to take the average values of the pressure. But in this case the pressure everywhere is same here, so I am multiplying directly here. Okay, so in this case, so we can write this is F is equals to, so we can write rho g, we can write specific weight of fluid y into A. This is the hydrostatic force exerted by this fluid of specific weight W on this plane surface. So this is the total force. Now let understand this one with some another way. So let calculate the volume of this case, yellow case. Obviously there is height of some case, there is some width, and there is some length of this case, so we can calculate what is the volume of this one. So height of this case is I think rho gy, that is the pressure intensity. Okay, so this is rho gy, and width into length we can say that is area, that is A here. So in this case the volume of this pressure intensity case will be height, that is rho gy, into area, that is A. So this is again we can write W y A. So you can see here rho gy into A, that is W y A, and this case W y A. So the volume of this case is also providing the force exerted by this fluid on this plate. Okay, we'll use this concept in the next cases. And now, so let suppose now that I'm saying here, as we know this is the center of gravity of this plate, so let I'm saying the depth of the center of gravity of this plate from the free surface is yc. The depth of the center of gravity of this plate from the free surface is yc, and obviously in this case, as the plate is in horizontal position, in that case y and yc will be equal. So first of all, I'm saying yc is depth of center of gravity from free surface of fluid. Okay, so in this case yc is equals to y, so I can replace this y by the yc here. So we can write F will be equals to WYCA. WYCA here. Okay, so point is clear, I think. Okay, so let's move on case 2. So our case 2 is hydrostatic static force on vertical plane surface. Okay, in the previous case we'll discuss horizontal plane surface, and in this case we'll discuss vertical plane surface. So now again we are considering this is our free surface of fluid. Okay, and in this fluid some vertical plane surface is submerged. So I'm taking some random shape or arbitrary shape. So this is our vertical plane surface. So this is the front view of this one. So side view, it has some thickness here. So just a minute. So this is the side view. It look like this one. Okay, so this is some arbitrary plane, vertical plane surface. This is the front view and this is the side view. Okay, so to solve this type of cases, so let's suppose first we have to consider a strip of dA area. Okay, and let this is y distance below the free surface of fluid. Okay, so this is the front view. So side view, here is the strip. This is area is dA, and this is y distance below the free surface of fluid. Again, the density of fluid is that I'm considering rho here, and g the gravitational acceleration. So the pressure intensity at this strip. So I think this is at y distance below. We can simply say by the using the hydrostatic law, that is the pressure intensity at this strip will be rho gy. It look like this one. So depth increases, pressure increases according to hydrostatic law. So here the pressure intensity at this strip, this is rho gy, and obviously above this strip the pressure intensity will be less, and below this strip the pressure intensity will be higher. Okay, so here I'm writing the pressure intensity P is equals to rho gy. Okay, so as we know the pressure intensity at this strip, I think we can calculate the elementary force on this strip, that is hydrostatic force. So we can write the elementary hydrostatic force on this strip will be the pressure intensity into the area of this strip, that is dA. So pressure intensity is rho gy, so we can write this is rho gy dA. This is the elementary force on this strip. So how can we calculate the total force? So simply by integrating this elementary force, we can calculate the total force exerted by this fluid on this vertical plane surface. So we can calculate that is F will be equals to integrating dF. So as rho is constant for fluid, J is constant, so we can take it out, integral y dA. Okay, because y is variable over this surface, and dA is also variable because there are different strips over here, so dA is also variable. So what is this y dA or integral y dA? So integral y dA is known as first moment of area. And how can we calculate this one? So to understand this one, suppose there is some I section. Okay, so this is our I section here, and for this I section we want to calculate the center of gravity of this I section from this axis. We want to calculate the center of gravity of this one. So obviously we know, in that case, first we divide this I section in three parts. This is my part 1, this is part 2, and this is part 3. Okay, now for this part 1 the area is A1. This area of this part 1 is A1, and let center of gravity of this part 1 around here, and this is at a distance y1 below this axis. Now for this part 2, let area is A2, and the center of gravity of this part 2 is y2 distance below from this reference line, and area of this part 3 is A3, and center of gravity of this part 3 is y3 distance below. So you are interested to calculate the center of gravity of this whole I section. So we can say that let's suppose the total area of this is A of this one. So I can write A and y bar. What is y bar? Y bar is actually the I center. If I'm writing around here, that is y bar is the center of gravity of this whole I section. So I can write A y bar is equals to A1 y1 plus A2 y2 plus A3 y3. Okay, so again we can simplify this one, so we can write that is y bar will be equals to, so I can write this is the sum of I is moving from 1 to 3, and this is AIYI divided by A. Okay, so this is this one, that is y bar. Y bar is the center of gravity of this whole I section from this reference point or reference line. So you can see here there is A y bar. So A y bar is actually the sum of A1 y1 plus A2 y2 plus A3 y3. Similarly, we can say this is integral is the sum of y and dA. There are so many steps here of dA, or different area, and the distance of that strips from this line is different, that is y1, y2, y3 and all these things. And by integrating yda, we are simply saying this will be equals to the total area of this one multiplied by the center of gravity distance of this body from this reference line or free surface. Okay, so let's suppose I'm saying around here is the center of gravity of this body, and let distance of center of gravity from the free surface is let yc. Okay, so for this case we can write that is integral yda is equals to yca. Okay, as in this case ay bar is equals to sum of all these things, so integral yda is equals to this one. So from here we can write f is equals to rho g, and we can replace integral yda by yca, and rho g we can write specific weight of fluid into yc into a. So this is the force exerted by this static fluid on this arbitrary vertical plane surface. Okay, but you can see here the formula, that is F equals to WYCA in this case, and the formula in the previous case is same, that is WYCA, and in this case also this is WYCA. But in this previous case the pressure intensity was uniformly distributed over the area, so we directly multiply pressure to the area here. But in this case you can see here the pressure intensity is variable. This is less here, it's going to be increased here, this is the maximum here. So why the formula is same here? So let's take a look here. We know this is our center of gravity, so this is our center of gravity line, this is around here, this is our center of gravity point here, so here is the CG. Okay, now the pressure intensity at this point at the center of gravity of the body, so we know the distance, that is yc, we know the density, that is rho, so we can write here this value is equals to, right, I'm using different color here, this value is equals to rho g yc. Okay, so here at the center of gravity the pressure intensity is rho g yc, and you can notice here this is also the pressure intensity at the center of gravity of the body, that is rho g yc. So here we are multiplying the pressure intensity at the center of gravity of the body to the area of this body, that is A. But why? Because the pressure intensity at the center of gravity of the body is actually presenting the average pressure acting over this entire vertical plane surface. And again I'm repeating this one. The pressure intensity at the center of gravity of the body is presenting the average pressure intensity acting over this vertical plane surface. So to understand this concept more clearly, we are taking one example here. So let's suppose this is the free surface of fluid. Okay, and we have a rectangular vertical plane surface over here. This is a rectangular plane surface over here. So let just a minute. This is our level here, and so this vertical plane surface, let's suppose if I'm saying the top edge of this vertical plane surface is y distance below the free surface of fluid. So this is y, this is also y, this is also y. This is our free surface of fluid. Now, and let height of this plane surface is h, and let width is b. This is b here. Okay, so we know that this is the center of gravity of this rectangular surface, and I think from the top edge this value is h by 2. So we can say this value is h by 2. Okay, so the pressure intensity over this vertical plane surface, so it look like this. So this is our free surface, and here the pressure is varying, acting over here. This is the bottom edge, pressure intensity remains same over here. So this is the pressure intensity, and it is varying over here. Okay, and at the top edge this is this much, this value, and at the top edge this will also remain same, because the distance of this top edge from the free surface is same, and it's varying like that over this rectangular surface. Okay, so this is the variable here. So now, so this is our case of pressure intensity as we discussed in case of horizontal plane system. So this is the variations of pressure over this vertical plane surface. So we know at the top edge of this rectangular plane surface the pressure intensity will be rho g y, because the top edge is at a distance y below the free surface here. So this value is rho g y. Okay, now the pressure intensity at the bottom surface or bottom edge will be, so the bottom edge is at a distance y plus h from the free surface. So this pressure intensity will be rho g y plus h. Okay, so you can see here this is varying over here. So as this is variable, we can't multiply the pressure intensity directly to this area here. That's why we have to find out the average pressure intensity acting on this vertical plane surface. So obviously the pressure is varying linearly. So to find out the average pressure, we can write, so P average will be, so let this will be equal to rho g y plus, so pressure intensity over here, that is rho g y plus h. Okay, this is h here, not p, this is h, divide by 2, and we'll get the average pressure intensity. So we can see here this is rho g is common, let's take it out here. So this is y, again this is y, so this is 2y, and this is h here. So this will be equals to rho g, so 2y by 2 is only y, and plus h by 2. Okay, this is P average. So our P average, that is the pressure, average pressure intensity acting over the surface, is rho g y plus h by 2. So let's check what is the pressure intensity at the center of gravity of this body. So the center of gravity of this body is at a distance y plus h by 2 below the free surface. Okay, this is y plus h by 2. So this pressure intensity, different color here. So this pressure intensity or this pressure intensity, that is equal to this pressure intensity. So this pressure intensity will be rho g y plus h by 2. And obviously you can notice here, that is this pressure intensity that is at the center of gravity of the body, and the average pressure intensity, that is rho g y plus h by 2, is same. So from this example it is clear, that is the pressure intensity at the center of gravity in case of vertical plane surface is actually presenting the average pressure intensity over the surface or over the plane surface. And so obviously, as we know the average pressure intensity, that is rho g y plus h by 2, and we know the area is, that is actually b into h. Okay, so we can say that is force F will be equals to P average into area. So P average is rho g y plus h by 2 into bh, and obviously we can say that there is this value, that is this is let yc. Yc is what? Yc is the distance of center of gravity of the body from the free surface of fluid. So we can write this is rho g, so this is yc over here, so yc, and this b into h is the area, and then we are getting rho g, we can write this is specific weight of fluid, and so this is yc and a. So again we are getting the same formula, that is wyca, that is over here. So I think point is clear. Now in the last case I told you, that is the volume of pressure intensity case will also be equals to the hydrostatic force, that is F. In this case, let try to calculate volume of this pressure intensity case. Okay, so obviously if you want to calculate the volume of this one, so we can simply say that let this is, we know this side, this is the, sorry, trapezium. Okay, this is the trapezium. So if you want to calculate the volume of this case, we can simply calculate the area of this trapezium, and then we can multiply this trapezium area to width of this plate and get the volume of this one. Okay, so let volume will be equals to, so area of trapezium into width, that is b. So what is the area of trapezium? So it will be 1 by 2 and sum of two parallel sides. So parallel sides are this one and this one. So this one is equals to rho gy. Okay, and this one is equals to rho gy plus h. So we can write this is rho gy one side plus rho gy plus h. Okay, into the height of the trapezium. So height of the trapezium is h. So in this case we can say that, let if I am taking this is rho gy plus rho gy, so this is 2 rho gy, so by 2, so this is only simply rho gy, and this is rho gh. So we can write this is rho gy, and this is h here, and plus, so this is rho gh and h also here, so this is rho gh square divided by 2 here. So this is the area. Then volume will be equals to, so volume is, so we can multiply this one by b, so this will be equals to rho g h b plus, so this will be rho g h square b by 2. So I think we can take common here rho g h and b. So we are taking common rho g h b. Sorry, so this is small b. So here remaining is y, and here is plus h by 2. Okay, now so again we know there is y plus h by 2 is yc, obviously. H into b is the area, and rho g is equals to w. So this we can write specific weight w. This y plus h by 2 is yc, and h into b is the area. So obviously this volume is equal to wyca, that is equal to the force, that is wyca. Okay, so yes, this will happen. The volume of this case or present density case will always be equal to the hydrostatic force exerted by the fluid on this surface. So I think points are clear. So if you have any doubt, you can comment, and if you like the video, then subscribe the channel and share the knowledge as much as you can. Thanks for watching. Take care of yourself.